Hello, honors. Well, I think we are in the last video of the year. So, let's be honest though, this video is going to be a few videos, so it's not the last, but it's like the last progression of videos, maybe? I don't know, no. Okay. So, let's get going. We're going to do the chapter 5 study guide. I'm going to put some paper under this because it's going to be difficult for me to write on it. Okay, so let's get going. It says, first problem, given the functions f of x equals 3x minus 5 and g of x equals 1 minus 2x squared, find f of g of x, then find its domain. So f of g of x, I just always like to just kind of rewrite that. F of g of x. And so what that's telling me to do is it's saying we're taking g of x. So we're taking this entire 1 minus 2x squared, and we're plugging that into f. So we're plugging that into f wherever there's an x. So what that means is that's going to be 3, and now instead of x, we're going to plug in g of x, which is that 1 minus 2x squared minus 5. Okay, so then what I would do is distribute that 3. So it would be 3 minus 6x squared minus 5. Combine like terms, so 3 minus 5 is negative 2. And that's it. That's my final answer. You can factor it, like if you wanted to factor out a negative 2 and write it like this. That's fine. It doesn't matter. I would not expect you guys to do that. So f of g of x is equal to negative 6x squared minus 2. Okay, so then the last thing it says, find its domain. Remember, when you're finding the domain of a composite function, that means we're inputting another function into another function. It's a conception of functions. What you need to do is you need to think about first, what's the domain of the function that you inputted? So we inputted g of x, so we need to first think about what's the domain of g of x. And the domain of g of x, well, g of x is a polynomial. And remember, whenever you're looking at a polynomial, sorry, I lost train of my thought there. Whenever you're looking at a polynomial, that means that the domain is always all real numbers. So let's write that g of x is a polynomial. So that means the domain of g of x is all real numbers. And then we need to look at what was inputted, and then we need to look at the new. And so the new one is also a polynomial. And so it's also going to be all real numbers. And then we technically would combine those, but they're the same. So the domain of f of g of x, oh, that's my timer. I'm going to finish my thought, and then I'm going to pause you here. So the domain of f of g is all real numbers also, because the new is also a polynomial. So negative 6x squared minus 2 is a polynomial. Ooh. Okay, so that is it for number 1. Let's move on to number 2. Okay, so number 2 is a little bit more complicated because we are dealing with fractions. So let's get into that. It's one of the ones that we did on the notes when we started this unit. Okay, so it's asking us again to find f of g of x. So I'm just going to rewrite it. So that means we're taking g of x, which is 1 over x, and plugging it in wherever there's an x and f. So here and here. Okay, so what does that mean? So if it's x plus 1, it's going to be 1 over x plus 1, because we replaced x for g of x, so 1 over x, divided by x, which again, we're plugging in g of x, so it's 1 over x minus 1. Now, I have a fraction over a fraction, or I have fraction on top here, and then a fraction on bottom. What I want to do is I want to separate them out. First, I think that helps me just to visualize it a little bit better. So I'm going to rewrite that as 1 over x plus 1, but I'm going to write it as 1 over 1, and then divided by 1 over x minus, again, I'm going to write that as 1 over 1. Now here, I need to get a common denominator. So to get the common denominator, I'm going to multiply top and bottom here by x over x. And then I'm also going to do it here, even though I'm just going to focus right now on the left side. So 1 over x plus x over x, which we're going to have to come up here. And then now that they have a common denominator, we can combine the top. So 1 plus x over x. And so now it's one fraction on the left side, and now I can deal with the right side. So that's going to be 1 over x minus x over x. Now that they have a common denominator, I can rewrite it as 1. So 1 minus x over x. Now I have one fraction on the left, one fraction on the right. Now I can flip and multiply. So 1 plus x over x times x over 1 minus x. I know, okay, my x's are going to cancel. And so then I'm left with 1 plus x over 1 minus x. Now I would rewrite this, but you don't have to. You can also say this is x plus 1 over negative x plus 1. Those are not going to cancel because negative x and x are not exactly the same. So those can't cancel. This is it. This is your final answer. So f of g of x is equal to x plus 1 over negative x plus 1. Now, just to come back to the not canceling part, if this was negative x minus 1, then you would actually be able to cancel because you can factor out that negative 1, and then it would be exactly the same, x plus 1 and x plus 1, and they would cancel. But because it's not exactly the same, that negative x and the x, you cannot cancel them. Okay, so then we need to find the domain. So first, we need to look at the domain of g of x. And that is a rational function. So remember, we're finding the excluded values. So I look at the denominator of g of x, which is x, and the denominator x cannot be equal to 0. So we have x can't be equal to 0. And that's it. There's nothing left to solve. Then we find the domain of nu, or of the nu function. And again, it's a rational function, so we're looking at just the denominator. So we're going to set the denominator, negative x plus 1 can't be equal to 0. Subtract 1, divide by negative 1, x can't be equal to 1. So when we write that combined, the domain of f of g of x, which I'm going to write below because it's going to be long. So if it can't be equal to 0 and it can't be equal to 1, the way that we write that is going to be negative infinity to 0, union 0 to 1, union 1 to infinity. Now remember, if you need to look at that on sometimes looking at a number line really helps kind of to see that visual. So if you need that visual, remember when we're doing this, okay, we know it can't be equal to 0. It can't be equal to 1. So we know, okay, it can't be here. It can't be here, but it can be everything else. So it's going to be negative infinity to 0, 0 to 1, 1 to infinity with parentheses in between there. And that is that. So that's 2. Remember, you guys, if you guys have any questions throughout this entire process, always email me, text me, call me, come to office hours, whatever you guys need. Happy to help you guys throughout the process. Okay, let's look at 3. So 3 says find the inverse of the function. So remember, finding the inverse of the function is taking the original function, and I'm just going to rewrite it as instead of f of x, I'm going to write y. So I'm going to rewrite this as y equals 2x plus 3 all over 5x minus 2. So when we're finding the inverse, remember, we're just swapping the x and the y values. So this is going to turn into x. That's going to turn into y, and then 5y minus 2. So remember here now, once we've swapped the x and the y values, our goal is to get y by itself. So we did an example. You had something like this in your homework. This one's kind of like the most common one that you're going to see. So there's like a process. It's literally the same process every single time. So our first step is to multiply both sides by the denominator, 5y minus 2. And so I have x times 5y minus 2 equals 2y plus 3. The denominator cancels out. Distribute 5xy minus 2x equals 2y plus 3. Move anything with a y term to the left side. So combine anything that has a y term. So I'm going to subtract 2y. And then anything that doesn't have a y term, we want to move to the other side. So I'm going to add 2x to this side. Now I have both of my terms that have y's in them here, so I can factor the y out with the GCF. So y is y times 5x minus 2 equals 2x plus 3. My timer again. I'm cooking chicken. I know you guys are all curious as to why I have a timer keep going off, and I'm cooking chicken. So there you have it. So then we would divide both sides. We now want to get y by itself, so we divide both sides by 5x minus 2. And so we finally get y by itself. So y is equal to 2x plus 3 over 5x minus 2. So remember, this is the way we use that like f of negative 1, like that little, it's basically saying the inverse. This is like a fancy way of saying writing the inverse. So we use that, and that is my final answer. So 2x plus 3 over 5x minus 2. Okay. So then we need to state the domain and the range of the function, and the domain and the range of the inverse as well. So let's start with just the domain of the original function, which is 2x plus 3 over 5x minus 2. It's a rational function, so we need to find the excluded values. So that means we need to set the denominator, 5x minus 2, can't be equal to 0 to find the excluded values. So add 2 to both sides, divide by 5, and x can't be equal to 2/5. Now remember, the way that we write that is in interval notation, so it's going to be negative infinity to 2/5 union 2/5 to infinity. Now, the range is something I can't find unless I'm looking at a graph or unless I'm looking at the inverse. Now remember, the domain of the original function is going to be the same as the the range of the inverse. So these are going to be the same, and that's how we find the range of the inverse. So the range of the inverse is going to be also negative infinity to 2/5 union 2/5 to infinity. And then to find the range of the original, we need to find the domain of the inverse. So the domain of the inverse, we're looking here, 5x minus 2 Oh, this one's the weird one. I forgot. I need to change this one. They turn out, I didn't even recognize it. The original 2x plus 3 over 5x minus 2 turns out to be the same as the inverse. That's so weird. It's just, I always forget this one. I need to write it down somewhere. But so the range, let's just treat it as if it was a totally different problem. We'd look at the denominator of the inverse. So 5x minus 2 can't be equal to 0. Add 2 to both sides. Divide both sides by 5. Again, x can't be equal to 2/5. So negative infinity to 2/5. Even though I know it's the range, it's still the same as the domain, so we're filling it in for both of these. This one's so funny. Let's actually look at the graph so we can kind of figure out why. So the domain of the inverse is going to give me the range of the original. So let's look at that graph. I'm going to get Desmos up here and see kind of why that looks the way it does. Remember, the inverse of a function is when it's reflected over the line y equals x. I'm typing it into Desmos. Let's see if I can get it here. So what actually happens, and I'm going to type in the line y equals x, is it's already, like the graph is already reflective on the line, on the line y equals x. So if I were to fold it along that line, it would already line up. And so that's why the inverse and the original function are the exact same thing, is because the original function, or if you were thinking about it in terms of inverse, they already are reflective amongst the line y equals x. So I don't know, maybe that's like a good conversation starter for that one. Okay, so let's see what the next, actually, I'm going to pause here since that's kind of like 5-1 and 5-2. And that kind of then leads us into exponential. So we'll pause here on this video and then pick up the next section, 5-3, in the next video. And that is that. So go take a break, do what you guys need to do, and come back, and we'll start the next type of questions.